In this lab session, we will have a hands-on experience on how to subset data based on rows and columns and summarize the data using aggregate function and cross-tabulation. First, let's load an inbuilt sample dataset, empty cars. Now, defining the range of rows and columns in the format rows and columns, we will subset first 4 rows and columns. For a specific list of rows and columns, define the positions of the rows and columns in a list using C246, again in the same format row and columns. Now we will use logical conditions to subset the data. First, with equal to operator. Table empty cars, then in the row section define empty cars $horsepower HP is equal to 93. Comma space for columns. Space will indicate are all columns. Now we have empty car data whose horsepower is equal to 93. One thing I would like to point it out that if we don't use comma, it will give results of columns is equal to 93. If we want empty cars data that has 93 horsepower or carburetor is equal to 1, in such case, we can use the OR operator if one of the condition is true. Else, if we want both the conditions like mileage MPG greater than 20 and horsepower smaller than 110, we can use the AND operator. Now, let's subset only the columns. Selecting the columns. We can select the columns by defining their names in list and the column section of row and columnar format. We can also apply logical conditions with the subsetting of columns. Here we have used a logical condition. Filter the data to empty cars underscore RC. If mileage is greater than 20 and horsepower HP smaller than 110, but display only WT, weight and displacement DISP columns. This is not that complicated. We are just using logical condition in the row section and defining the list of columns in the column section of the row columnar format. Even we can add a new column using a logical condition. For example, here if MPG is greater than equal to 15, label as luxury. Again, if MPG smaller than is equal to 20, label sports, else economy. In the new column, add. Let me show you the new column. Here we have our new column successfully added. And to remove a column, just point null to the column. Manipulate data using which. Which operator returns only the indices, that is the positions of the logical condition if true. Let's first load a sample data. Now, using which function, we will save the positions whose number of doors is equal to 2. Head index underscore position. The list of position whose number of doors is equal to 2. Now, we can subset the data using the position that we have just saved in the index underscore position object. If we want to subset only the rows, then mention index underscore position in the row section of the row columnar format. View new data. We have our empty car data whose number of doors is equal to 2. Order. Order function is used to sort the data either in ascending or descending order. By default, it takes ascending order, and for descending order, we have to minus. We can also save the sorting values in R object and use it to sort the dataset. Or else, directly define in the row columnar format, order the rows using sample data $sl.no, that is the serial number. Another important function to get a quick summary of our data is by using the aggregate function. Like for example, if we want the average mileage based on cylinder, Then type mpg by is equal to list. This means the output will be displayed in a list and the last the function name min. Else we have tapply function as an alternative to aggregate function. We can also define the aggregate function like this, where fun means function. The difference between the two is here we have used empty cars and here we didn't. Because here we are indicating R to get the data from the object empty cars. The advantage of this aggregate function is that we can do multivariable analysis. For instance, if you want the average mileage based on cylinder as well as with carb, then just add the second variable carb after the CYL. That's it, easy and intuitive. Now, if you want the total average based on cylinder, we just have to define the variable CYL inside the list function. Cross-tabulation using table. Table uses the cross-classifying factors to build a contingency table of the counts at each combination of factor levels. For instance, number of empty cars based on transmission AM and cylinder CYL. Type table empty cars $am, empty cars $CYL. Done. In the output, we can observe that 4, 6, 8 are the types of cylinder and 0 for automatic and 1 for manual. So we have 3 cars of 4 cylinders with automatic transmission. Again, we have 8 cars of 4 cylinders with manual transmission, and so on. So this is how the cross-tabulation gives the counts at each combination of factor levels. Next, we will learn more easy way to manipulate data using a special package called dplyr.